Hello. Today I'll be talking about school bus safety. Every single morning, about 25 million students step onto a yellow school bus, trusting that it's the safest ride on the road. According to the National Highway Traffic Safety Administration, in their official safety report, school buses are statistically 70% safer than an actual car or passenger vehicle. As a former school bus driver, holding a commercial driver's license, and as a parent whose own kids ride a school bus every single day, I have seen the engineering safety system from both sides of the wheel. First, I will explain how seat design protects students through compartmentalization under Federal Motor Vehicle Safety Standard 222. Second, I will discuss how bodies are engineered for rollover protection and joint integrity under Safety Standards 220 and 221. Third, I will share how historical collision data, specifically the tragic 1988 Carlton bus crash, led directly to mandatory modern safety upgrades and driver emergency standards. To begin with, my first point, let's look at how the bus seat itself acts as a personal protective shield for students. Under Federal Motor Vehicle Safety Standard 222, large school buses do not rely on traditional seatbelts because they use passive safety system known as compartmentalization. I have a video queued up for you guys. During a front or rear impact, the seat frame flexes and padded cushion absorbs the energy, effectively trapping the student inside a protective bundle. This design eliminates the risk of seatbelt entanglement and ensures students can evacuate rapidly during an emergency. This eliminates the risk of seatbelt entanglement and ensures students can evacuate rapidly during an emergency. Moving on to my second point. While the internal seatbelt padding protects children from the inside, the heavy-duty steel frame protects them from the external impact forces. Under Federal Standard 220, school bus roofs are constructed with reinforced steel cage bows, capable of supporting over 1.5 times the vehicle's total weight during a rollover. Additionally, Federal Standard 221 mandates that strict joint integrity regulations, according to research published by the Transportation Research Board, body panel joints must retain at least 60% of the raw material's strength to prevent external panels from shearing off and penetrating the passenger's cabin during a collision. Turning now to my third point, these federal safety engineering standards did not happen by accident. They were forged through real-world crash investigations and rigorous driving execution. In 1988, the devastating Carlton, Kentucky bus collision, where a drunk driver struck a school bus, resulting in 27 tragic fatalities, primarily due to post-impact fire and blocked rear exits. According to the National Transportation Safety Board official crash reports, this tragedy directly forced federal updates requiring heavy steel cage shielding around fuel tanks under Standard 301, non-flammable seat materials, and additional emergency push-out windows and the roof hatches. Furthermore, even the best engineering relies on trained personnel with CDL drivers undergoing mandatory pre-trip safety inspections, emergency evacuation protocols, and strict route safety management to ensure these physical safety barriers perform as designed. In conclusion, school bus safety is a comprehensive system combining of engineering and operational training. To review our main points, first we examined how seat compartmentalization under Standard 222 absorbs impact energy. Second, we looked at how structural rollover and joint standards under sections 220 and 221 protect the cabin frame. Third, we discussed how historical lessons from 1988 Carlton bus crash transformed fuel tanks, shielding, and emergency exit standards supported by the CDL driver. Next, Whenever you see a school bus on the road, you can appreciate a lifetime of engineering, history, and standards built into every single mile. Thank you.